using REST API to work with storage services. See, so far we have seen that we can make use of .NET SDK. We wrote code in C# to access the storage account and work with blob or table or queue or file system. In all cases, the code which we wrote was very specific to .NET, though simple but was specific to .NET. But what if in case I want to write a client application which is not in .NET but is in something like Java or maybe JavaScript jQuery combination or PHP or Python? In those kind of cases, we cannot make use of the .NET SDK. So what is the alternative? One universal solution which is provided is using REST API. Now, basic advantage of REST is platform independent and is majorly made up of two things, that is HTTP and I can say REST is equal to HTTP plus either we use JSON or we use XML for the data. So HTTP is the protocol which is going to carry the data, and the data will be, let us say, in either XML or JSON format. So that's what is RESTful protocol. And REST is universal. REST is supported by almost every language and technology today. So one big advantage with most of the Azure services is, though right now we are going to deal with storage service, but almost all other services of Azure are also going to provide support for writing client application using REST API. So yes, it becomes very important from that angle that you understand how REST clients can be written for communicating with various Azure services. In specific, in this particular session, I'm going to deal with storage service. But before I proceed little more, remember we are going to submit a request from client to service. So there we have to provide a URL and we have to provide a request method. Basically two things. One is the request URL and the request method. Now based on the request method, an action will be performed on the server. So what are the possible request methods? We have got request methods like HTTP GET, HTTP POST, HTTP HTTP merge, HTTP delete, and there are few more, but these are enough. So based on these methods, an action is going to be performed on the server. Of course, the action also will depend on the URL. So if suppose I have a URL, let us say something like this. I have a URL like this. What am I trying to do here? This URL with HTTP GET method is to fetch all the details of all the customers which are available in the storage account by table name customers. So we have customers as the table name, all the identities which are there in that table. We want to fetch that, provided the method used is get. But the same URL with method post would be used for adding a new customer there. Likewise, the same URL with method put will be used for editing or updating the existing customer there. And the URL, of course, when it is put, merge or delete, is also supposed to have the ID, something like a partition key combination. So this is going to get me all the customers. This is going to get me only a particular customer for which the partition key and row key is going to match. And here we are going to get customers where we are doing the filter, where we are saying the rating is greater than or equal to some 3. This percentage 20 is for space. Spaces are not allowed, hence they are encoded. And rating is less than or equal to 6. Between 3 and 6. If rating is there, then only get all the customers. And what do we want to get? Instead of getting all the details of a given customer, we want to fetch only the 3 columns: partition key, row key, and address. So like this, we have to frame the URL, which is an important part of REST API. 2, we have to choose the appropriate method. And 3, we have to submit the data, at least in case of post, merge, delete. We have to submit the data, and that data is supposed to be either in JSON or XML format. Then a complete REST request is going to be submitted from client to server. So we are going to demonstrate this. First, I would like to write a HTTP client, RESTful client in C Sharp. But in subsequent session, I'm going to also show you how we can write a HTTP or RESTful client in JavaScript jQuery. So first, I'll create a new project. Of course, at this particular point of time, we are not going to add a new get reference to the project. We just take a simple console based application and I'll call it as RESTful client for table storage. I'm going to use HTTP. For that, I'm going to add the reference to system.web and system.web.extensions because we want to make AJAX calls, HTTP calls, RESTful calls. Then now what I'll do is I'll delete all this and let me copy the code from my handout. Let me clarify, this code is pretty complex for the first time for you to understand. But of course, once we understand, it will be quite easy and we can reuse it in multiple places. The complete project, I'm just copying it as it is. I don't need everything at one go. Let me collapse everything. So here you see, we are having one helper class, Azure storage constants. In this Azure storage constants, we are supposed to have the URL. This is demo storage is the name of my storage account which I have created earlier. And I have to take from here the key. This is the key. I'll copy and I'll paste it here. I'm going to have in my demo table storage, so table endpoint. I'm also going to have a demo for queue, so queue endpoint. This is the key which I have copied and something called as shared key authorization scheme. This is for basically generating a shared key for authentication purpose. So that should be shared key as it is. You don't have to change it. Then I have replicating my table, a class called as employee. I'm going to create object of this class and add to the table. I'm going to get objects of this class only back from the server. So partition key, row key, email, age are the four things we have here. Employee collection. Basically, when we want to get multiple items, we want to make use of this employee collection. So we are going to use these two classes, employee and employee collection, for serialization and deserialization. Then I have main. Right now, all the five methods. I have an example for insert. I have an example for getting only one employee. I have an example for getting all the employees. I have an example for updating an employee. I have an example for deleting an employee. I'm going to uncomment one at a time and explain to you all this code. So let us say we want to begin with first insert. But let me clarify. Before this, you should ensure that your table is already created by name employees. My code is taking a table called as employee as the base. And whatever is there in this table, I would like to delete it. It's blank. Nothing should be there in the table. We'll do everything from scratch. So I want to now insert an employee. So I wrote a helper method, insert employee, to which I'm passing training as the partition key, row key as Sandeep, email ID, and some age. Now what is this method doing? This method using this data is creating an employee object. Pretty simple. Now, here we are not going to work with employee object when sending the data from client to server. Because it is all REST, we have to convert everything to JSON format or let's say in string format. So that is the reason we are using here JavaScript serializer, and we are converting the object into string format. This string I would like to submit to server, and when we are making a HTTP call, AJAX call, the content is going to be submitted in the form of byte array. So using UTF-8 encoding, we are converting the string into byte array. So this is the content I would like to submit along with the request when I'm going to make a HTTP call. So here I wrote one more helper method called as build request. The build request is going to construct a HTTP request object. Now we have that method here. I would like to explain this method later, but right now let us have the understanding of the basic code. So build request is going to build a request using HTTP post method. Employees is what is the URL we want to submit the request to, and this is the content I would like to submit to server. So build request is creating a HTTP request object with all these inputs, and that request I will submit to server over here. So here from our client application right now C sharp, we are submitting a request to server. Once we submit the request to server, server is going to provide some response that we are getting it here in the form of stream. And that stream, as it is writing it on the content. That means, oh no, sorry. Actually, here we are not submitting the request. Here we are only getting the stream reference. Here we are submitting the request. We are getting the response from server here. Here we are getting the stream of the request, and to that stream we are writing the content. Zero, the content by buffer offset from which index of the buffer and how much of the content. All that content we are writing to the stream. So once we have the data in the stream here, here we are submitting the request, getting the response. Then from response we are getting the response stream. We know that the response stream which we are going to serve from server will have an employee object, the newly created employee object. That employee object we are deserializing it here and we are returning it as a reference. So insert employee inserts with all this data an employee object in server and also returns an employee reference. The new object is created. So I repeat once again, with the parameters here, we are creating an employee object. We are serializing it, converting it into byte array. We are building a request. Pretty decent amount of code goes into this method, and I'm postponing the explanation of this little later. I'm going to discuss. Here we are going to get the stream where we are writing the content which we want to send, which is nothing but the byte array with employee object, and that request will then be sent to server. Server is going to create a new employee, return a reference to HTTP web response. From that HTTP web response, we are getting the stream, which we are again deserializing an employee object and returning the reference to it. So if I run this program now, with this as it is, let me clarify. I haven't explained build request, and build request is internally making use of create authorization header. This is where actually the security will be taken care of. Nowhere we are providing key right now, but yes, there is code for key, and that is in create authorization header. So let us run this program now. I just press Ctrl and F5, and we'll see that by the time this program ends successfully, though it should successfully terminate. Now we will see that in our employee table we should have that record. Refresh, and we should have it. Training, Sandeep, date, email, age. Timestamp is the extra column which is automatically provided for the table. So that simple is insert. Let's now look at the next one. I want to get the employee which is inserted. So I'll comment this and I want to get. So what will be the URL? URL will be employees of the partition key and the row key. And the partition key row key is what we are passing it here as parameter. So training, whatever we can record inserted, same thing I should get it. So this is the URL which we want to use now. So again we are building a request. with this URL path, get method this time, not post. The employees only, but we are putting a filter condition in bracket. Only a particular employee having so and so partition and row key. Build request, get response, and once we have the response, get the stream. From the response, we'll deserialize the object, which is employee. So the whole stream is JavaScript serializer used for constructing the employee. And that employee reference we are written. Let me put a breakpoint here and run. We should get that employee. Expand it. You see 40, Sandeep, training, so on. As simple as this. It is simple. Again and again I'm repeating because complicated logic has all been encapsulated inside build request. I have hidden it. Now let's stop it. This time I would like to now get all the employees. How do we get all the employees? To get all the employees, the URL is again supposed to be employees. If you just leave it as employees, we will get all the employees irrespective of their partition key or any other condition. But here what we are doing is, we are, actually this is not required. We are putting a query string here, filter. Filter is a parameter through which we are saying that we want to get only those partition keys which are equal to training. Remember, this is EQ. So all employees, that means all the entities in the employees table where the partition key is equal to training. If you want, you can remove this part. Just leave it like this. All the employees will get. Again, as usual, build request. Now, when we build this request and get the response, what we will get is an array, the JSON object, and that JSON object is supposed to have a property called as values, which is an array of employee objects. So because of that only, here the class has been written with value as a property, which is going to get me the list of employee, or it can be an array of employee, whatever. So let me actually put a breakpoint here. I'll make you understand. This is important. Until here, it's all common code. Whatever response we get, we are getting that in the string format. From the string, we would like to deserialize it. So let's run this program. Once it breaks there, now let us try to understand the string. We'll call it as JSON visualizer. So you see here in JSON visualizer, we have a property called as value, and value will have an array. Of course, in my case, only one item is there, and that is nothing but an employee object. So the main object has a property by name value, which is an array of employee. And keeping that structure in mind only, I had to write this class. Then only deserialization would happen. This value is an array of employee, which is going to get deserialized over here. Just press F10 and you'll see here list of employees has one employee. That is very, very, very important. Employees collection. So what is that you have to note here? This one. Along with filter or not, it's your choice. So we are done with insert, get one, get all. Like that we have got update. So when we want to update, always remember we have to update on the condition of partition key and row key. That means first we have to get a particular employee which we want to update. So the URL is going to refer to that particular employee entity. Employees of with so and so partition key and so row key. Then we have to create a new object which we want to update. Obviously, partition key, row key we don't update. We will always update other details only. So here we have got JavaScript serializer, converting the employee object into byte array, like in add. Now we are using here the method called as merge. What is merge? There are actually two methods, put and merge. The basic difference between put and merge is if put is used, all the properties will get updated. Whereas if merge is used, only those properties which you have mentioned in content will get updated. For example, in this particular case, of course, I have mentioned both email ID and age. But if I do not give age, only email ID will get updated and age will not be modified. Old age will remain. But if I have used put here, it is expected to provide both age as well as email ID. All the properties are supposed to be provided in case of put. So both put and merge are used for updation only. URL path, that is this one. Content is the new employee object. So same story, just this differs from that of add. We are getting the stream, writing to the stream, sending the request. Of course, we are not getting anything from the server, so we are ignoring it. But of course, after this, you'll notice that here I'm going to update, let us say, the email ID and the age. Both are getting updated. So once I run this program and if it successfully terminates, we will go back to the storage account table and see that these values are updated after I refresh. Perfect. So that is how update command is working. And finally, we are now left with delete. Delete is also pretty simple. You have to just provide the entity to be deleted, specific entity identified by partition key and row key, and then method used must be delete. Rest all is same, and there is no content here. That's why content is null, because here itself the identity is there for a particular entity. So content is required only in case of update and insert. Otherwise, delete, get, we don't need content. So get response stream, and once we get the stream, we are reading the stream though, but we are not getting anything from there. So even if you don't want, you can ignore it. It's your choice. And if I run this program, the new entity which was created will get deleted because it is matching so and so. Perfect. Delete it. Refresh it, and it's gone. You don't have anything. Now run the same program again. We are going to get exception. We are actually supposed to do exception handling in these kind of cases. 404 error. Something like file not found, 404 error. Entity is not found. So it is throwing a web exception which we'll have to handle it. System.net.web exception 404 is the status code. Likewise, same thing would happen in case of update also. If an entity with so and so row key and partition key is not there, it is going to throw an exception. So now that we have understood clearly how these methods are executed, let us now understand the core logic which is there in building a HTTP request together with authorization header. So to build a request, we need content type. So that is how we are getting JSON. If you don't give that, default is XML, or you can give up application slash XML. So here what I have done is I have provided a link where you can probably learn more in detail if needed. Let's go to this page. I'll click it again. Azure Storage REST API reference. And here you see we have got storage service REST. And under that, for each one, there is a separate section. So storage requires you to put a HTTP request, all basic information. Let's say we want to go to queue service, no, table service REST API. Now, what is that we want to do? We want to invoke different operations. Like I want to get an entity, merge an entity, delete an entity. Let's take delete an entity or maybe insert an entity. Now, here it is clear if you have to execute this RESTful request, what should be the request method? What should be the request URI? This is the URI which we have to frame. This is the table, storage table name. And if you are using emulator locally, then you'll have to use this URL. And along with the request, these are the headers which we are supposed to submit. The most important of all here is the authorization. Authorization is supposed to contain the shared access key. Now, how to create that shared access key? I'll go to that next, but you'll have to go here to look at the shared access key. Otherwise, you have to mention date, version, content type. That's what I told you. Atom plus XML or JSON. You can give any one of them. Version prior to 2015, 12, 11 only support XML, but now it's all JSON. Everywhere, everybody is using JSON. Content length. When we are submitting the content, which is a byte array, what is the length of it? That we'll have to provide. And what is the parameter accept? The content type of the response payload when we are going to get from server. What response we are expecting from server? That we'll have to provide here. Prefer, and of course these are all optional. Accept, prefer, all these are optional, but this is required, this is required, this is required, this is required. These two are the most important ones. Now let us go to authorization. The authorization header. So when you are framing an authorization header for blob and queue, blob queue file services, you have to give shared key scheme, version blah blah blah. For table services, you have to give this, and so on, some information. Most important thing is at the bottom here. Constructing a signature. This is how you'll have to frame a signature. And this is actually separated in multiple lines. If you put all of them in one line, it will be like this. So here slash and which are left empty, the default values. This left as default. Explanation is provided. And with all this, you'll have to get a authorization key, which is in this particular format. Shared key, our storage account name, and some shared access. How does this shared access key get created? For creating this shared access key, first we have to create a string in this particular format. We encode the string by using HMA SHA-256 algorithm or UTF-8 encoding. Basically, this is given one procedure. So after reading all this procedure, I wrote this code. Let's understand now. So yes, I would strongly recommend you to go through this particular page completely from beginning to end. If in case you have to write a RESTful client, really useful. But to the extent possible, let me explain here. So I'm taking three variables: content type, date. Now the date format which is required here is compulsory in UTC format only, invariant culture. So you have to create a UTC format of the date. It has to be in this form only. Storage service version. Of course, every storage account has a version. This is the latest right now. Authorization header, which I am creating using another function. So this forming of this string and encrypting is all done by this function, which I'll explain little later. The authorization header is created. That authorization header have to pass it as authorization of request header. So I'm creating request object HTTP web request for the URI. What is URI? The table endpoint plus the request path. What is the request path? Slash employees class employees of partition key and row key, that request path that is coming from here. The request method is used here for request dot method. If content is there, that means it is not equal to null. Then only we are specifying content dot length and content type. We are giving content type as JSON. And these are all other request headers as specified in the documentation. Now, only in case of delete and put, we have to provide one special request header, that is if match, which I have to give it as generally the e tag of the entity which has to be either updated or deleted. But here I'm not interested in handling the concurrency issue, so I'm not worrying about e tag, and hence I have given star. So let me explain you about e tag. Now what is e tag? Now let us say we have got the storage account at one place and there are two users working with it, user 1 and user 2. And if both the users, if they get the same entity, let's say training Sandeep, Sandeep at the rate pss.com and some age 40, and same entity details are fetched by this user also. And what is there in the backend? In backend, of course, right now, let us say we have this value only. So this is there in the table storage. User 1 has fetched this, user 2 has fetched this. Now let us say user 1 makes the change, user 2 also makes the change. Now when user 1 does an update, obviously because this is the first user, it will get updated in backend and it will become 41. But now the issue is when the user 2 fetched data, it was 40, and now when it is updating, it is 42. So, don't you think whatever changes were made by user 1, without seeing those changes, user 2 is going to overwrite it? Or take the worst case. This will keep it as 40 only. This is changed to, let's say, Sandeep Soni at dss.com. So now user 2 will overwrite this record. So this will now become what? Sandeep Soni, and here it will become 40. So what will happen to these changes? They're overwritten, they're lost. User 2 does not know that the row was modified and it was overwritten. So that is where the e tag will come into the picture. So there is some e tag which is there for every record. So let us say we go back to the original state. So this is what we will fetch now. We will fetch the entity. Along with the entity, we are also going to get the e tag. Now what I am going to do is I'll update this to 41, and let's say here I changed it to Sony. Now if this entity is updated, backend is going to check the e tag provided here and the e tag here are matching or not. If only they are matching, the change here will be reflected and thus this will become 1. But the moment this is changed, this e tag will be changed. Remember that. This got modified. So now, if this user is going to do an update, the e tag which was fetched here is X, whereas the e tag here is already changed to Y. So immediately this user update will get rejected. He will get an error. Runtime error would be thrown. It will not be updated. So that is actually the importance of e tag. So when we are updating an entity, in case we want, we can fetch the existing e tag and give here the new e tag and give here that value which we got from backend. Of course, to keep it simple, I'm just putting it star. In case you are interested, you'll have to learn little more about it and go ahead. Of course, you may want to read from internet about it in more detail. But yes, e tag is basically used either with update or with delete, so that the data which I'm trying to delete or update should not have been modified before I do an update. That means somebody else should not have modified after I have fetched. That's the purpose of e tag. So yes, very quick understanding. Build request is building the HTTP web request. For building HTTP web request, we have to create HTTP web request object by using the create method with the specified URI. The URI here is the combination of the table endpoint with the requested path. Once we have the request, we have to associate content type and content length, provided we are submitting the content to it. We have to also provide accept, which is for what type of data we are going to accept from server to client. We are saying JSON. Then we have got the request method, get or post or merge or delete or yeah, any one of get, post, merge, delete, put, any one of them. And some additional headers. These are supposed to be provided as per the documentation. So what are the valid headers? You'll have to learn from here. For every method, there are headers listed. Like if I take you to delete, there I'll show you that here if match is required. Because if match is not there in case of insert, force an unconditional delete, then if match should be given as star. Otherwise, you have to mention it as e tag. So each header, as per the requirement of the method, you'll have to provide. Most important of this is authorization. Now, how is authorization header created? I am passing to authorization header four parameters: the request method, request path, content, and the date in RFC format. So this comes here. MD5 for hashing. Content type is JSON. URL path. Now, when we have the URL path, for creating an authorization key, we should not have query string. So in case there is a query string like filter or order, we are trimming that off. We are removing the query string. If it is there, anything after question mark, we are ignoring and taking only the first part of it. Canonicalized resource, which is the storage account name and the that is here. URL path without query string. Now, also very important to note here, if content is there, in such case we will have to use content type. If content is not there, content MD5 and content type are not required. Just slash and slash n is enough. Very important. So the way you frame the string, which is further encoded, get a signature, which is further in combination with shared key authorization scheme, that is shared key value, the account name, and the signature. These three things together become the authorization header. So let me now put a breakpoint. One of this example I'll use now, maybe insert. Actually, I would like to place breakpoint not here, but here, and place the whole code line by line. Start. It will break at build request. F10. F10. We got the date in this particular format. Only the date is supposed to be specified. Storage service version, constant value. Create authorization header. Now, very, very important thing, whatever is the date value used here, which is passed along with request, same thing should be used for constructing the authorization header. Even 1 second difference for submitting a request and authorization header creation, if the date values are different, then it is not going to work. It will throw an error. So you have to get the date of the system only once and use the same value for both creation of the authorization header as well as submitting a HTTP request. The request header MS date must be same. Believe me, it took 6 hours for me to identify this error. I was not giving the same date and I was always getting the authorization header error. So please record this once again. The value used for creating a authorization header and the value for header XMS date must be same. That's why I did it once and used it multiple times. Then go down. Oh, it's already scrolled. So I pressed F10 instead of pressing. Let me once again go through this. Just go back and use F11, MD5, empty. There's nothing to split because URL path is just employees unequal resource where we have got the storage account name along with the path, and all these parameters are clubbed together in string to sign. You see the post /n/n because MD5 is empty. Application /JSON, OData, no metadata, and so on. Date is used here. Whatever has been passed there has been used here, and canonical resource. That string with the key, this is where the Azure key is used, and that we are converting it into byte array. From byte array, we are getting a string. So this is the key which we are supposed to use while submitting the request, the signature. Together with, see there, the shared key, DSS demo storage, colon, the key which was generated, the signature which was generated. Shared key is a constant, like that only you have to give. All this return, authorization header, URI, we have framed the URI, we got the request object, setting the properties of the request object, adding headers to the request object, and return. And now stream, so that the response is, the request includes the new employee object. We get the response from server, and from that response, we'll get the new employee object. So like this, we are operating. That's it. So very, very important. Create authorization header and bad build request. I have separated them. Now, one more reason why I have separated them rather than writing in same place is this method I would use for generating a shared access key, which I can give it to client if I am writing in JavaScript. See, the problem with JavaScript is if I give the main key in the client, the main key will get exposed to the users. This key we cannot afford to give. This is the main key. So using this main key and the other data in the request, we are generating a sub key whose validity is for 15 minutes. And with that sub key, the client will directly access the request, I mean the storage account. After that, it will expire. So temporary key is what this is generating. Right now, we are building a C# code. We are writing code in C#. Everything is at one place. But when I move to RESTful client in JavaScript, what I will do is create authorization header. I will write on server. This will return a string which will be pulled from client, which is a sub key. And using that key, we are going to submit a request for insert, update, delete, or get operations. I would strongly recommend you to go through this particular chapter once again, listen to this particular session once again. Little complex, but one more advantage of this is how you are going to build a RESTful client in case you want to for not only storage service but for all other service. The way you build a request, you build a authorization header, those are all going to remain common. What will change? The URLs format and the HTTP method based on the requirement. You'll have to choose one of them. Thank you.